everybody, you're watching Mr. Fugu Data Science. Today we're featuring Mongolite using RStudio for our interface, and it's going to feature the lookup operator. I need to distinguish something for you. You need to pay attention. If you're using this, it only works if you're in the same database as the collections you're working with. Secondly, if you have very large files, do not use the lookup operator, or if you must do so, consider indexing, creating references, or using something like a match. Now that I preface with that, here's my socials. Hit me up. Also, I have the community tab for my page if you want to leave some comments for suggestions and videos, or just feel free in this video if you'd like to do that. All the code will be in the link in the description. Shameless plug. I have a buy me a coffee. You could consider a channel membership or throwing a super thanks. I'm sorry, but I gotta do it. Here's the imports we're going to use. Hopefully, even though these are a little outdated in the specs, if you have something newer, I hope there's no compatibility issues. I cannot guarantee that. After I create my connection to Mongo here, you have this option, like for example, if I was creating this database and wanted to query through it, like looking for collections or anything like that you see here. But I kept getting some issues when I was trying to run that. I listed my databases so I could show you what we're going to work with today. If you've never used this before, this is just giving you some syntax which can help. We create on the fly, as you see here, this collection as well as database. It will not be populated until you throw something in. So if you try to query while you're making something on the fly, nothing will show up. I'm just letting you be aware of that if you've never done this before. I used my terminal and made a connection to mongodb. Here's the collection that I'm throwing in, and I'm specifying this ID just for fun with this dummy data set. I capitalize the I because it throws us off for our IDs, which are created within Mongo. We have some character types, which are Pokemon, and then whatever their description is. No, this is not the correct number for Pikachu or Mew or Charizard or whatever, right? I just made those up. So if you're a die-hard Pokemon fan, don't bash me in the comments. This is just for fun. Here's the data that I threw in. This is very important here for when we're doing the lookup operator, and I'm going to show you why when we do the aggregation. We have a separate collection we're going to throw in to our new database, which is this. It's called Poke Orders, and we're having an ID, an item, which is Pikachu, an Indeedee, which is similar to what you saw for the character type above. We have a price and a quantity of the cards available. We're creating this on the fly once again, but I changed this variable name so when I'm doing queries, I don't confuse myself to understand what I'm looking for. I inserted those in, and we're good to go. And here's what it looks like when we do the query. We do the lookup operation like this. We have this dollar notation, we do the aggregate, and this single quotation is important versus this double quotation. So think of this as like our key value pairs where I'm doing the double notation, and I have this lookup operator with the dollar sign. How do we exactly read this aggregation for a lookup? We're taking this, which is the very first collection we did. This is going to be the Poke characters that we're dealing with here. So we're taking the Poke characters and we're going to look up the other collection, Poke Orders, and we're taking in our current local collection of Poke characters the character type, and from the Poke Orders we're going to look at the item to do the comparison, and we're doing a left outer join. I should throw a picture up on the screen so you understand what's going on. When we print this out, it's going to give a new column called inventory sales data, which is going to store it as a list, and that's what you see here. That's what we're dealing with. Let's see if maybe I should zoom this in a little bit to help you out. Hopefully it doesn't pixelate later. This looks kind of odd because you're thinking to yourself, well, okay, now I got this list, but now I don't have any variable names for this list, which is kind of problematic. I mentioned earlier about these right here for these NA values, or this incomplete, which is very important. This is intentional because when you're doing a comparison for a lookup operation, you're going to do the comparison for your local collection, the one you're starting with. You're doing a collection against the from, which is the foreign collection, and if something is not in there during that comparison, you're going to end up with null values. You're also having a backwards comparison where you're doing a foreign field comparing it with your local field, and if that doesn't work, you'll have a null value, and that's what's going on here. So what do we exactly work with? The character type, which is Pikachu, Indeedee, Charizard, etc., and comparing it to see if it was available in the other collection, and that's what you see here. And because it was available in this specific collection, we're good to go. We print it out with all the information, and this is the referencing number that we have stored from Mongo. This is an ID or an object ID representation. These 300s are interesting because when you did the character type here, you had NA values, so those NA values are basically the same same, and now you're just printing out the ID numbers which are associated with this. When you print it out and you actually look at what's inside of that inventory sales list for each entry, you see that it indeed has the actual key value pairs, and that's what's going on with your key is the column name, and then your values are the rows of information, which is perfect. So if you needed to parse that, you have that ability. We can do a separate aggregation where now we're looking at taking these data, but instead we want to flatten, unnest your column that we have. So to zoom out a little bit, and we import the library of tidyr to do this. You will reach a problem because you have columns, for example, that are repeating in information. Because you have repeating information like this or like this, you have an issue, and it will give an error to you unless you handle it. And so that's what I'm doing here, because one, I want to have unique names for the columns. Two, I decided to have it all printed out even though I have repeating information. So you see these rows, these object IDs, these are the same thing for referencing. So that's how I accounted for this. Let's look at one more example where we use a pipeline. If we're using a pipeline that you see here, we're starting off doing this with a let. But what is let doing for us? This is kind of interesting because think of it as allowing you to access an input for a collection where the variables are defined inside of the let, which is allowing us to use it as a reference. We're taking the ID from the pokey characters and you're using a single $sign. This is important. We are then using the pipeline to execute for the collection on the join. We have a match, we have an expression, and an and, each of which need to have the dollar symbols. And I have this equation where I'm saying, let's look at our new variable we named pokey underscore for a double $sign now, which is your reference from the variable of the let. And then this is from the foreign field that we're getting from the other collection, because we're allowing us to distinguish the names since they were similar or the same in this case, allowing for a proper comparison, and as is allowing us to print out the new column called match IDs. The single $sign foreign collection variables, double $sign references for the let statement. This is the printout of the list that we had, and here's all of the information. Let's look at another example real quick that was adapted from online that I had, and it's all in the citations in the bottom. Just these were adapted a little bit. Let's say we have this collection called post, and here's the information where we have a title, author, insta likes, and we have this one, which is a collection called comments, where they're both in the same database, and you have post title, comment, and likes. Let's do some kind of aggregation with a lookup. So we perform this lookup where we're taking, this is code from MongoDB, not code from Mongolite. This is specific code for that. If we're using just Mongo in the shell or wherever, we would do it something like this. We're looking from our local field for the current collection of Instapost, where we want to do a lookup for the foreign collection of comments, and we're going to look at the insta likes and the title, and we're changing the variable names to post likes and post title. We're using the same exact thing we did before, but this has two operations where we're doing a greater than, and we're doing the same thing with a comparison of the likes. The first thing, remember, this is going to be the reference from here where we're taking our insta likes. The next thing we're going to do is take our post title and make it as a comparison with our foreign field. We're going to display everything as a new column of lists called comments. The output that we're going to have is going to be something like this, where we have the original data from the left side that we were doing the comparison with, which is our local field, and then we have a list of whatever prints out from the right side. The right side in this case will be the comparison for the greater than, where we're taking the like values. So we have a like value from the local field is greater than the like value for the foreign field, and you're printing off everything that was in the foreign field. In this case, on the other hand, you did not have the greater than problem, and you had to end up with an empty list of values. I need to mention this because it's extremely important. Potential issues with speed. I said at the very beginning, if you're going to do this and you want speed, even without the lookup operator, always consider investigating indexes. Indexes are a great thing, and consider the index, for example, on the the foreign field. Another good thing is you could look at profiling to track the speed of your operations. You could print it out, you can make graphs, you could do whatever you want. There's some links in the bottom if you really die hard about getting into this stuff. Nested collections are going to definitely screw you up when you're trying to get speed. The match operator should be considered over the lookup operator because you're doing less comparisons. Stop all of this and read it at your own leisure. It's extremely important and it'll help you with stress and frustration later. Believe me. The young lady who reached out to me from Spain. So thank you for giving me this idea for this video. I greatly appreciate it. You know who you are. The speed up options for your Mongo life. Indexing. Consider storing subqueries in separate documents for faster reads. Consider doing some referencing. If you're in a situation where, let's say, you're saving an ID from one document into another, what use cases may help you? If you had a many-to-many relationship, it's pretty good to use referencing, but understand you are making more round-trip calls. And if you have documents where it's bigger than 16 megabytes in size, maybe you should consider doing a reference. If you have something that is updated and grows relative to other parts of the document, consider it. Embedding. Think about this if you have nested documents. This can help you with accessing the same items at once and improve your read times. Another thing, not all one-to-one relationships could benefit from embedding into a document, and one-to-many relationships are pretty good for embedding. And what am I talking about embedding? Think of making a file. Since you're already looking at the same file, consider like making it nested is kind of what I'm talking about. Since you're already going to look at a document, consider throwing it into a collection and storing everything all at once. That's kind of the point of that. So you're making less round-trip calls. And then if you have really large files, you should absolutely consider replication and sharding. Really consider that. Here's some basic examples real quick for indexing: adding an index on multiple fields, removing an index, and removing all indices. This is notation that would be relative towards RStudio because of this. Just pay attention to that. Pause the video if you would like to go through these and understand what's going on. Last things to mention: flattening list, like the unwind operator, but that's different than the unnesting we did earlier, which was on a data frame. But that'll be it for this video. So thank you. Please like, share, and subscribe. And if you subscribe, turn on that notification bell. Hit me up on my socials, and remember, if you would like to help support the channel, consider buying me a coffee, throwing a super thanks, or a channel membership. It'd be greatly appreciated, and I'll get back to Patreon at some time. Notable mention here, thank you to all the members who have helped support the channel and reached out and gave me ideas over the last 2.5 years to make videos. I appreciate all of you. Thank you. Bye. Data science, computer programming.
Hey kid, don't ever let them get inside your head.